एक बार ऑडियो चेक कर लीजिए सर, कुछ भी बोल दीजिए।
Hello.
Yes, sir.
Is it okay? Everything
Yes, sir.
seems
Seems
alright.
pro-
Yeah.
Yes, sir.
Right. All the best.
Thank you, sir.
ग्रुप में सर हैं। हाँ बोलो।
बोला था क्या मैं
Sir, we'll begin with the session now.
Yes, ma'am, please.
Okay, sir.
इस पर check कर लीजिए slides.
Good afternoon, everyone. I welcome you all to the day 2, session 2 for the 15-day refresher program. Our next speaker is Dr. K.S. Mishra. Before starting with the lecture, I'd like to introduce sir. Dr. K.S. Mishra is basically a geologist specialized in the application of remote sensing techniques for exploration and management of water resources. Sir has served in Geological Survey of India for over 36 years. He has attended geological mapping, exploration, engineering, and environmental projects in various terrains of the country. During his 2 stints in Canada, he has obtained PhD from the University of Manitoba, Winnipeg, with specialization in remote sensing and geophysics. Sir has later received Canadian Government Laboratory Visiting Fellowship to work in Canada's Centre for Remote Sensing, Ottawa, and involving application of microwave remote sensing. On his deputation to Centre of Studies in Resources Engineering in IIT Bombay, he has explored groundwater in central India. He has developed techniques for preparation of geological, geomorphologic, and hydrogeomorphological maps by utilization of remote sensing data. As the head of Remote Sensing Application Center, Bhopal, Sir has trained scientists and provided sites for borewells in Prime Minister's Drinking Water Mission and Environmental Impact Assessment. Sir has also suggested over 6,000 borewell sites and achieved 92% success rate, even in difficult regions of Madhya Pradesh. As a distinguished professor in the University of Petroleum and Energy Studies, Dehradun, he has taught applied geology for BTech and MTech students, water resource exploration, and has guided 5 research fellows for PhD. He has also conducted courses on exploration and management of water resources at Center of Studies in Resources Engineering, IIT Bombay, and Remote Sensing Application Center, Bhopal. Sir has been regular visiting faculty to National Water Academy and Groundwater Survey and Development Agency, Pune Water Resources, and Public Health Engineering Department of Madhya Pradesh and Groundwater Department of Gujarat Government, Gandhinagar. Sir is presently continuing research in transfer of water from surplus to deficient river basins, site selection for tube wells, and rejuvenation of Himalayan springs. Sir is going to talk to us about new climate change parameters, environmental, water security for teachers and researchers. Sir, it's an honor to have you amongst us. Without any further ado, I would request you to kindly address the gathering.
Wonderful. So, in this show and tell, what I'm going to show and tell how we can have environmental and water security. And this is designed for the teachers and active researchers in this field. Let me start with Antarctica. Antarctica is a huge continent known as White Continent because it is mostly covered by ice and snow. And scientists didn't know much about it because going there is a hazardous, very difficult to work in minus 40 degrees centigrade temperature. And by field methods, some data was getting collected by different parties from different countries of the world. Even remote sensing didn't work, didn't provide details about Antarctica because for 6 months it is dark because it is located right on the southern pole where there is a 6 months night period. And when 6 months there was a sunshine, radiance values are very strong. Everything is white, so images are not very sharp. So it was very difficult to get anything. But fortunately, Canadians have launched a radar satellite which collects data in radar wavelength, and that has started providing a lot of good data. So this white image is from the satellite, and this is an image from the radar set, the Canadian satellite. And here you can see a lot of details have started emerging. Radar, as you know, is a color-blind system, and everything is shown with the tones of black and white. So what these tones mean, I'll explain to you now. See, first thing which has been provided and has been of very great interest are these black and white lines which you are seeing across this image. And these are snow dunes. You might be aware that winds, they pile up sand, and sand dunes form in desert regions. Antarctica, there is no sand, only snow and snow and snow. So that is piled up by the winds in the form of dunes, snow dunes. And these lines which you are seeing running across the image are only 1 to 1.5 meters high. So appreciate that this image is taken from a distance of 600 kilometers radar image, where you can see something which is only having elevation of 1 to 1.5 kilometers. And then we started looking at it and working on it. And what we found that they can be used as very important climatic parameters, because these dunes are accumulated under a special type of climatic condition during the interglacial periods. You might be aware that last 2 million years have witnessed 4 major glacial cycles, and these glacial cycles are separated by interglacial periods. So what has happened during glacial cycle? The Earth has become very cold, temperatures have dropped, aridity has increased, and winds were blowing, very strong winds were there. So most of the deserts have formed during this period. And in interglacial period, they were wet, humid, and temperatures were little less lower in Antarctica. Well, everything is lower in sub-freezing only. So blizzard conditions, very strong winds, very high, heavy snowfall has taken place during such periods when these snow dunes are accumulated. And later they are consolidated. These are rock solid, and they have been consolidated during the glacial period, which was very, very cold. So we get information that in pristine, because this is an area where there is no human interference, no trees, no deforestation, nothing. So in this pristine environment, we can study the climate changes better than any other part of the world. And this has been repeated. Say, in one cycle, the snow dunes are formed. In another cycle, snow has got accumulated as sheets, and that has also got consolidated. So we could work out that there was a period of glaciation and then interglaciation, glaciation and interglaciation. So this has provided geologists that, well, this is a natural phenomena which is going on surface of the earth during last 2 million years. How it was separated, what were the unique conditions, all this is very, very interesting for climatologists. Here you can see this is detailed view of the snow dunes, and a geologist will ascertain why they are terminating along straight lines marked here as a red. So a lot of more geological information from one information to other information we have been deriving from Antarctica. This is the total picture of Antarctica, and all over the globe people have worked and they have identified 3 or 4 regions where these snow dunes are there. And we worked for 3 years, and what we have identified is that 4 more areas which are marked by yellow. So in any understanding, first thing is to get the disposition, how they occur, where they occur, how the winds were blowing, because one side is gentler, windward side, and other side, leeward side is steeper. So we start deriving the inferences. Of late, we have recognized, the climatologists have recognized that volcanic eruptions play a vital role in change of climate. This is one of the main geological phenomena which can change the climate on the Earth to a large extent. Here you can see another satellite picture of Antarctica, and there are volcanoes from which the fumarolic activity is still taking place. The smoke is coming out from the volcanoes. Wind direction can be ascertained, and they keep on erupting, and then they become dormant during certain times. You can see here again how the volcanoes look like in field. So volcanic vents are there through which the fumarolic activities, fumes are still emerging along a straight line. So this is from Antarctica. This is the largest volcano in Antarctica, highest and largest, and lava keeps on getting erupted in a spasmodic way. Sometimes the latest has erupted what you see as a black material which has come out from the volcano. These volcanoes are as fields, they are there in agglomeration together, and they have erupted and became dormant, again erupted. But more important things are volcanic fields. So in Antarctica, there are innumerable volcanic fields comprising hundreds of volcanoes. And from volcano, what we have marked is that lava tubes and channels are coming out. So these are very interesting phenomena, because when lava comes out to the surface, it gets cooled and solidifies. It doesn't move to long distances. And if the channels are there, normal channels are occupied by the lava, and then roofing takes place because it starts getting solidifies from the sides, and then roofing takes place, and then through the insulated tube, lava can reach to long distances. So this is for the first time our group has identified lava tube. Here you can see that there is a volcano on the northeastern part of the image, and on the southern side, the lava tube is coming out. Each and every volcano, more than 5,000 volcanoes are mapped in Antarctica. You can see that they are there. And you can see that from this volcano, the lava tubes are emanating in different directions. 2 very prominent are there on the southern side. Another series of volcanoes, and you can see the lava tube is coming out on the southern side. These lava tubes are very, very interesting and tell about climatic conditions. Say this is from a picture from Hawaii, and you can see that there is a volcano on top of the image, and through which the lava is flowing, and sometimes they are very wide and they braid, and lava keeps on moving for a longer distances through them. Similar structures we have found, say we are sitting in West Bhopal, we are sitting in volcanic rocks, and from here right up to Bombay, the rocks are volcanics. And these volcanics have also traveled through the channels, and these are the remnants of those lava channels. So if you map these remnants, you can see from which direction, where was the volcano, how the lava has got traveled to long distances. This is very close to Pune. There is a place known as Ahmednagar, and north of Ahmednagar, 10 kilometers, we have found this system of lava channels and lava tubes. This is a lava tube, completely insulated. It is about 30 meters across, and huge amount of lava, we presume, would have traveled through this tube to long distances. The importance of these lava channels, because a huge lava channel means a huge eruption. This is a picture of our neighboring planet towards the sun, the Venus. So Venus, as you know, is covered by an envelope of about 400 kilometer thick sulfur dioxide, carbon monoxide, carbon dioxide gases, and you can't see the surface of the Venus. But again, thanks to radar, because radar penetrates through the cloud cover, mist, haze, and everything. So we have started getting beautiful pictures of the Venus. And in the central part, you can see that there is a huge volcano, and lava channels and lava tubes are coming and flowing towards the west. It is so enormous volcanism which has taken place on Venus that the present day temperatures on Venus are something close to 400 degrees centigrade. So life cannot survive. Only sulfur springs are there and lava channels are there. These lava channels, so if volcanism of this proportion can take place, it can just make our environment impossible to breathe and live. This is the situation on our nearest planet towards the sun. And when we will come back to this little later, but when we come back to the Mars, the other side of the Earth, you find there are dunes. And this is a picture of the dunes, and winds are ferocious. Very strong winds are there. And dunes, you can see they are composed of huge boulders. And these boulders are aligned along a straight line. So this is a desert again. So what we have on Mars, no water presently, dunes and dunes and dunes, and strong winds. So our condition, will it become like this? So we have to see our planets, and then we can say what will happen. Say these are the dunes, mapping is done. These are again a picture of dunes from the Martian surface. Rocks are there on Mars. Channels are there. So once you have channels on Mars, that means at one time, there was a water on Mars and it was flowing through the channels. Now these channels are dry and they are occupied by the sand ridges. You can see the channels here. They are at one time, they were occupied by the water. You can see the rills. Your mountains are there, water falling from, they're coming down from the hills in the form of streams and rills can be seen here. So this is the surface of Mars. So there were rains, there was water, and where they are terminating, you can see the ground is swollen a little bit. That means the water has gone down and then the earth has swollen in those areas. So this was the scenario on Mars. Yeah, this is a picture interpretation of it. And you can see this is again Mars, where the blue areas which are colored here are oceanic regions. Rivers, you can see, are opening in the ocean from all the sides. Mars is famous for the impact because it is located very close to asteroid belt, where billions and billions of asteroids are just going around the sun. On one side is Jupiter, and on other side is Mars of this asteroid belt. Apart from this asteroid belt, there are Trojan agglomerates which are running in along the path of the Jupiter. So Jupiter has got very high gravity and it dislodges these meteorites. The first victim is the Mars. And Mars surface is just thumped by innumerable meteorites. And you can see in blue areas, they are less. That means it was occupied by water. And in land areas, the impacting is more prominent. So water acted like a cushion, and that's why they are less. So up to quite some time ago, there was a water, and water of oceanic proportion was there on Mars. And how it is lost, this is one thing we have to ponder, understand, and save our Earth from a catastrophe where we can lose the water. You can see this is the interpretation where ocean, rivers, land areas, and impacts are marked. This is also an impact structure. You can see that is how the Mars is impacted. And as I told, there are a lot of sand dunes. You can see in the center of the impact, there are dunes. This is another impact structure. A huge impact structure has taken place. So coming back to a few slides, which I skipped, I'll show you that what are other parameters by which we can understand the climatic conditions. So we were talking about volcanoes. Say in Antarctica, volcanoes, because volcano is a source of heat. So here you can see that a mountain is created by melting of the snow and ice by the heat of a volcano. And these are sometimes huge. Something, say, this area which is covered by this volcano around it, melting has taken place, is something equal to, roughly equal to Uttar Pradesh. So that much of area, the ice and snow was melted at one time. So repeated thawing and freezing is very interesting phenomena on the surface of the Mars. You can see this is another area where melting of snow and ice has been done by the hidden volcano, which is located below. And channels, because when melting takes place, the water starts flowing. So from radar interferometry, how much water in which direction it has flowed can be ascertained. So if you lift the cover of snow and ice in Antarctica, you will find that what is shown here with the lights is the area where volcanoes are located and they are melting the ice and snow. So when the ice and snow in Antarctica will get melted, the sea level will rise and reflectance will increase. A lot of climatic interferences will be there. And when the snowfall in Antarctica will be more, the sea level will go down, aridity will increase, and beaches will be exposed to winds which will carry the sand, and deserts will form. So the climatic condition in Antarctica to a large extent controls the climatic conditions of the entire globe. Here is the largest glacier on the surface of the Earth. The Lambert Glacier is shown here in Antarctica. How several glaciers, they joined together. So how the glaciers are melting in Himalayas, are receding. This is what tells about climatic conditions, whether in last 30 years, if we find that the glaciers have receded, many of the glaciers in the east have receded, but in the west, they have advanced. So regions we can find out where glaciers are receding or where they are advancing. So all these phenomena by remote sensing can be studied throughout the globe. So this is very interesting science to watch the glaciers, how they are moving, how they are, say for example here, this whole valley was at one time in Antarctica was filled with the ice and snow, but heat started coming, glacier has got melted, and you can see in the central part, only one stream is there through which the water is flowing. So by these assertions, you can find out the effect of volcanism, and volcanism has been colossal and spasmodic all over the globe in different geological times. Another feature by which the glaciation and interglaciation can be established is whether the ice is receding or advancing. Here, strand lines in Antarctica are mapped. Here you can see on the northern shore of Antarctica, the glaciers, the ice has receded. So from various features associated with glaciers, this can be ascertained how much it has receded or advanced in how much time. In Himalayas, we have worked, say the blue areas in Western Himalaya shows snow cover. One is in the month of February, you can see a lot of area is covered by blue color. That means snow cover is a very heavy, high, large area is covered during the winter months up to February, March. And in the August, you can see only very small portions are left which are covered by the snow and ice. So like this different months, over years, you can find out whether we are advancing, our snow cover is advancing or it is depleting. This helps us to calculate how much water will be available, because it is this snow and ice melt that provides water to the Gangetic system, and very large amount of population is living of the population is controlled by the melting of water and availability of water, good quality water in our river systems. So this is a very important for water security to understand, map the cover of snow and ice in our mountain ranges. The oceanic ice in oceans at high latitude, the freezing and thawing, it keeps on happening. So what is happening to sea ice? That is also remote sensing can tell about it. Where are the icebergs? How much water is there? How much ice is there? That can be estimated. Sometimes freak of climatic conditions, they tell that there is going to be a major climatic change. This is a picture few years ago. It is from Sahara Desert. Yellow are these sand dunes and white areas are where the snowfall has taken place. So snowfall in Sahara is something very unique, and this has been photographed. And this I have already explained about the Martian surface. And from Martian surface, we come to the climatic conditions again. So this is the scenario which was there in Carboniferous times, the times when huge forest cover was there. And these forests, they got dwindled due to climatic change. They fell down and they made the coal. That's why it is known as Carboniferous time. So during the early part of Carboniferous period, there was a huge forest cover and lot of oxygen. And with lot of food and oxygen, the creatures were very big. You can see here a fossil of dragonfly, which is spanning something like 3 feet. So huge insects, even the insects were huge during this period, because so if you want, the population should have a lot of things to eat and it should be larger, then a lot of food and oxygen is needed. Here you can see an animal, ammonoid, how big it is, the size you can estimate. This lived, they are extinct, but their nearest cousin is this nautilus. It is found in present-day sea, and its size is very small, not even 1/10 of what it was earlier. So at that time, there was a lot of food available in the oceans also. So if the food is available, the creatures will become bigger and bigger. Similarly, these are insects. You can see from the size of umbrella, which is kept here, that the normal creature, how it was earlier, and with a lot of food available, lot of oxygen available, how big it has become over geological time. So this is what is a very important, whether our population, whether the individuals, the creatures, the insects, the animals, they are becoming bigger or they are becoming smaller. That is also an indication of climatic conditions. If we talk about last 2 million years, in geological history, there have been innumerable climatic changes. I told about Gondwana Carboniferous period, that is something like 280 million years ago. But here you can see this is within our reach. You see last 2 million years, the Quaternary era. This was glaciation in southern hemisphere, entire Antarctica, part of Africa, southern Africa, part of southeastern, southern America, India, and Australia. They were together. They all got frozen. And Europe was frozen. You can see the area which was covered. So this covered Europe and large part of the. So during glacial cycles, when aridity prevailed, deserts were forming, big rivers in Africa like Nile, Niger, Senegal, and Congo, they also dried, you see, in the mid-courses. So that was the severity of this glaciation which is taking place in polar region, but it affected the entire globe. And when food was available, these are the creatures, somewhat cousin of elephants with lot of hairs to protect themselves from cold weather, woolly mammoths. They were there. And as glaciation progressed, there was not much material available for them to eat. And they started, you see, dwindling in size, and reproduction stopped. And finally, they all died. You see, they vanished. They are not found anymore. They are extinct species. And all this has happened in last 2 million years. So this is what is the importance of the climate change. Say in high latitude areas of Siberia, they have found that there were normal conditions because animals, they were grazing, and grass is in their mouth, it is in their esophagus, in the gullet and stomach. And they suddenly froze. The grass is frozen to something like -53. and got preserved in the same fashion. So this is something, the climate change can also take place within seconds, because the animals will not keep on eating up to the very last moment. If it will start getting cold, they will start doing something else than eating, running around, panicking. But here they kept on eating and they got frozen. So this is the climate we have to understand. Suddenly a blizzard-like thing will come, and it will, from normal temperatures, it will drop, temperatures will drop down to something like minus 40, 50, and entire thing will get frozen. Now, water security we have to talk about. Say, for example, our desert region of Rajasthan, Kutch, parts of northern Gujarat, and Haryana, they are drought prone. They are the regions how to get water in Rajasthan. So very many efforts have been made. Drill holes are done, water is provided. But what we attempt here is to map the channels. Say, below the snow cover, sand cover, there is an integrated system of rivers. You can see here that these are the rivers which are there in existence in the Rajasthan desert. These are the channel courses. They are bouldery, sandy, and they are presently, you can identify without special remote sensing techniques. Here we have used thermal imaging, radar, and combined to map them. Now, here in these channels, if you drill borehole, you can get water. And you can get good amount of water. But because there is a lot of salt from Run of Kutch, you can see in the southern portion, where desiccation of sea waters takes place, and the salt is also blown to the desert region. So a lot of water is saline. And here, if we want good amount of water, then on northern reaches, if we keep on recharging these paleochannels, we can pick the water, wash the salt content in it, and use it. So these are the channels which are a potential for good amount of water supply. They can be recharged, and there is no loss of water due to evaporation, which happens in case of canals, and they have got natural channels. Contamination will not be there because canal water gets contaminated many times. And here, because it is constantly getting filtered through gravel, through boulder, through pebbles and sand. So it remains a good water, moving water. So this is how we can secure the water supply to entire desert and dry regions of our country. Himalaya is water tower. Nature has made it in such a way that ice and snow, which we have discussed, gets deposited on top of the hills, and that melts gradually to provide water. So these are our water towers. Nature it accumulates during the period when there is a snowing and provides us by melting in the summer months. So nature is helping now. How we can help ourselves in coordination with nature. Say, this is a picture where you can see that there is ice, it is receding, and then there is a zone where you have got a lot of glacial lakes, moraines, everything. And what happens, these lakes, when they burst, a lot of water is released armed with boulders, cobbles, pebbles, and causes destruction. So in this region, if we take precaution, we strengthen these lakes, we can store water and release it when we need. In doing this, we can also generate electricity. So instead of generating electricity downstream and taking it to the mountain region, locally we can generate electricity, store the water and release it whenever we need. So this will protect us from instant floods, breaches in lakes which cause disaster like Kedarnath tragedy, or recently there was a Rishiganga tragedy associated with such a feature. Now, something you might be wondering, what is the climatic pattern? So here you know that Indian continent, subcontinent gets the monsoon from the Arabian side, the southwesterly monsoon, and one arm of it comes from the Bay of Bengal, the southeastern arm. And sometimes the Arabian arm is more active. And then those monsoon months, we get a lot of rainfall on the western side, like this year. This year we had a lot of rainfall starting from Karnataka, Maharashtra, Gujarat, Rajasthan, several spells of flooding and heavy spells, even in central western part of Madhya Pradesh. We had a lot of rainfall, including our Malwa region. So this is why it is happening. That is to be investigated. But it is seen that sometimes this arm is active, and if this arm is active, the budget is same, then the southeastern arm is less active, and we have got deficient rainfall in parts of Uttar Pradesh, Bihar, and eastern India. So this is what is happening. We had very deficient rainfall in this side. But the most interesting phenomena which you might be wondering is nowadays we are listening about cloud burst. Why there is so much heavy rainfall in the Himalayan region. Say the worst scenario is created when a cyclonic or depression from the monsoon reaches close to the Himalayan region, and it is impinged, it is stopped by the westerly disturbances. So westerly disturbances are those which are coming from western side, from are generated over the Mediterranean Sea, move over Iran, then they come to Afghanistan, Pakistan, and then they start snowing. Mostly they are in the winter months. But the phenomena recently, which in 20 years we are observing, is this, that westerly disturbances are becoming more and more common. And whenever westerly disturbance is stopped, or a monsoonal depression is stopped by westerly disturbances, both of them start dumping the water together. And that is what is causing much of the cloud burst. A lot of cloud bursts have happened in the past. And if you see the satellite picture showing the cloud disposition, you will find that such situation occurred during the Kedarnath tragedy. It happened little later in Ladakh area, and it happens many times in Himachal Pradesh. They are more prone, western parts are more prone to this type of cloud bursts. Now, water security for peninsular India. Say, this is the map of India, and the southern part of Narmada, now a region south of Narmada, is deficient in rainfall, most of it, except the western portion, the Bombay and Konkan and Kerala region, where rainfall is something like 400 inches, as good as northeastern region, highest rainfall region. And just after that, we have rain shadow area of the Western Ghat Mountains, and it is having deficient monsoons, deficient rainfall. So if we can bring this lot of water from the western side towards the eastern side of these mountains, well, we have secured the water. Rivers emanating from east on the eastern side like Godavari, Krishna, Kaveri, and many other smaller rivers which flow towards the east they are deficient in rainfall. And so how geology and geomorphology favors that this water from west can be brought to the east. You know, when there is a lot of rainfall, the gates are opened. And today, if you see the scenario, it is exactly like this. This is the last reservoir on Narmada River. All gates are opened and the water is going to the ocean. Gates of Bargi Reservoir close to Jabalpur, Maheshwar, Omkareshwar, Punasa, all are open now. So we have 7 dams on Narmada and we have to open them to release the water. Now, if we go for something like 30 dams, which is supported by the science, geology and geomorphology of the Narmada, then we can store this water, bring it south and provide it to deficient regions. So once we have so much of rain, we release the water and then we have got shortage of water following months. So this is what is needed to balance the water. This is the topography of the area. This is on the western side is Bombay and on the eastern side. So if we store the water, the green color shows the hill profile. And if we store the water in the depressions in the green area and make the tunnels, we can get that water towards the eastern side. It could not be done earlier because the tunneling was very, very difficult process. Now you might be listening every day that long tunnels are dug in the mountain regions. And that is because of the improvement in technology and very fast they can be done. So water management is, say presently we are taking water to Bombay from the Ghats, top of the Western Ghats, which is not needed. You can store the water. Bombay receives very heavy amount of rainfall, as I told, 400 inches, and that can be stored and can be made Bombay can be made self-sufficient, not only for present requirements, but for coming projections, for coming years, say 5 years, 10 years, 20 years, because water is the population will be more, Bombay will be more vibrant, more water will be needed, and we must secure that. So we have to plan in such a way that the water is available in future years also. You can't carry the water from west to east in this scenario. So geology and geomorphology, the earlier picture, this one is close to the Nasik, the place from where the Godavari River emerges. This is close to Bombay. You can see that towering mountains suddenly rise and storage is only on top of the mountains. Well, top of the mountains receive very high rainfall also. So that water can be stored. And this is the final map which shows that on Narmada, you have to make some dams, store the water, and then through the Satpura hills, there are corridors through which you can bring it down by natural flow. You don't have to pump it or anything. Just tunneling and canal can help you to bring that water to the Tapi River. And from Tapi, you can drop on the eastern side of the Western Ghats on all these rivers which are deficient in rain. This is the scenario, and a lot of data is required. We are generating more and more data every day. And for Bombay, presently, Bombay gets water from a reservoir shown here in the blue color. But we are going to suggest what is shown in shaded color. And if that river is tapped, water will be flowing to Bombay, and it will be available for at least 20 to 25 years, including the projections. This is how we can use it. We can bring the water from the west, make a canal, and then the water keeps on flowing towards the south, and we get a gradient of about something like 300 meters. So water will automatically flow. No lifting is required. And when we cut a tunnel at the end of the portal, we can generate electricity also, drop as much water as it is needed in the successive rivers. So a meticulous planning can be done. Up till now, not much of geology, geomorphology has been utilized in these planning, but what I recommend that if our engineer brothers, they use this information, they can do better planning for the future. Now, remote sensing is providing a lot of good data. Each and every stream can be traced on a radar image. This is radar image of the Western Ghat Mountains. This is north of Bombay. Barren area, no forests will get submerged. We can store the water in Wag River and augment the supply for the Bombay city. So these are the maps, how much will be the submerged area, where is the hills, what are the... So all this information can be gathered by remote sensing and GIS techniques. So these are the career prospects. I keep on talking to teachers, you see, that where is the career prospects, and best career prospects are available with the remote sensing GIS techniques. And if anybody pursues these studies, he can be a very good person available for management of the water resources. You can see here on western side, a lot of water is flowing and going to the ocean. This is again going to the ocean, but it can be tapped and taken to the eastern side. I'll end my presentation with one very significant, where our ancients, you see, they were so wise and in managing the water. Say Bijapur city, which has presently 3 lakh population, is deficient in rainfall and means of water supply. And after every 15 days, water is given for 2 hours. That is the situation. But in the historical times, it had a population of 10 lakhs and water was provided both in the morning and evening to the entire population. How they were doing it? They were doing it by contour canals. Along the hills, they made the canals, stored the water in tanks, and that here you can see that there is a tunnel. Now they are reopening those tunnels from where the water was coming. So water was trickling in these tunnels, and then those tunnels were opening at a reservoir, and then that water was provided. So if these tunnels are opened, whatever rainfall is there, it will drop into these tunnels, it will go into the reservoirs, and then it will be provided. So our ancient wisdom needs to be used in management of the water to a large extent. With these words, I end my presentation, and if there are any questions, I'll love to answer them.
Thank you so much, sir. It was indeed a very informative session. I request all the participants, if they have any questions, they can post it in the chat box. So meanwhile, I have a few questions. What are the basic steps which can be taken by an academician to make changes in the society regarding the climate change?
Say academicians are the backbone. They are the people who inculcate the interest in the little ones. So if they present that, well, there is a lot of scope in management of water engineering, water resource engineering, and get them, you see, interested in the subject from the very beginning. They will start reading about it, and then they will find it is more and more interesting. So that is how the interest will be created. So first thing is teachers. Well, I'm here because teachers have created interest in science. They have created interest in various subjects. So that is what is very important. That is what they can do very well.
Indeed, sir. So what will be the challenges which are usually faced? I mean, throughout your career, you have had you're a institution in yourself while you talk about the climate change. What kind of challenges you have faced in your career aspects regarding the climate change perspective?
Yeah, the biggest challenge is this, that in any field, I will say, why climate change only? The doctor, if you talk to a doctor, he has got a challenge to face the quacks. You see, the quacks are there, and innumerable of them are there, and they pose a lot of challenges. So when they spoil the case, people go to the regular doctor. So here also in climate change, anybody and everybody gets up and starts telling he is a climate change specialist. He may not be knowing anything about climate change, but the climate change is the buzzword, and everybody has become a climate change person. And they keep on creating a lot of misinformation, disinformation, and they turn off the people because they don't know what they are talking. So climate change is a very, very difficult, because it is not only one subject, it's a agglomeration of so many subjects, and one has to understand that. And we don't have courses in climatology. We don't have courses where people can be trained in climate science, and their word should be heard by the decision makers. So decision makers, I find that they are also in trouble because they don't know what to do. Somebody says you make that dam, somebody says no, dams are disastrous. Somebody will say, no, you link the rivers, you transfer the water. No, it is going to be a disaster. So like this, you see, we have to come to the consensus what we have to do for the future. And that is the challenge of the day.
Absolutely, sir. I think the lack of awareness also plays a very important role in the challenges which we are having. So there's one question. Apart from the question, there have been a lot of compliments for you, sir. Everybody's enjoyed the session thoroughly. So one of the participants has asked that, can you suggest how the water crisis in India can be solved?
Well, I gave information about water crisis. You see, what happens? Say, nowadays, a lot of rains are there. So we don't have any policy. We have got policy how to get rid of the water. Yes. Dump it somewhere, throw it somewhere, pump it out somewhere. We don't have a policy for mitigating the floods. If we would have had a policy, the flood water can be channeled to such a place where it can be stored. Underground is the best storage. You see, recharge the river basins, store. And then after the rainfall, then few months are okay when water is available, and then the crisis starts. So we should have a persistent policy for throughout the year, and not only for the year, it should be for drought years, because luckily for now, last 15 years, we never experienced drought, but there were droughts in Bihar, 2067, 66. My God, that was terrible. So we should have water for those years also. That is my concern, that so much of water is gone. If we would have had the place to store to meet the requirements of the drought or deficient rainfall years, and they are not, well, we are lucky, but 15 times we are lucky, but sometimes we may be not that lucky.
Definitely, sir. Sir, there's one more question. What is the probable threat of climate change in near future for human civilization?
Can you repeat your question? I could not listen.
What is the probable threat of climate change in near future in human civilization?
Okay, so if we study our civilization of few centuries, so most of our civilization, you see, Mohenjo-daro and Harappa and all this, they were along rivers. And there was a Saraswati river, which is an extension of Ghaggar river emanating from the Himalaya. That was the river along which, say, last information I have, say something like 429 archaeological sites are located. That means people were living in those areas for 400. Now there are no civilizations. So what has happened? When water started becoming deficient, people have migrated. There was dust storms, sandstorms, which covered the river basin, and it became difficult for them to live. So they migrated. So this is a historical fact that with the change of climate, with the change in the pattern of availability of natural resources, particularly water, if it starts becoming deficient, the trees start getting dried up, forests we lose, green cover is lost, and over years it becomes non-habitable place, and that's how the people move. So if we closely monitor what is the cyclic pattern of these, people have done it and they have come to the conclusion that the cyclicity is there, and that is how the huge migrations take place with the change in the climatic conditions, availability of natural resources.
Thank you so much for that information, sir. And there's one more question. So what is your opinion about borewells as in most part of India, which are being used? What is your opinion about borewells, sir?
Shall I give you my honest opinion?
Definitely, sir.
See, a successful borewell is one where there is water available at shallower depth. It is available throughout the year, and it is available in formidable quantity. But our governments, for appeasing, they say, we'll give you free electricity. And the farmers, you give free electricity, they will keep on pumping out the water all the time, whether they need it or not. And that's how we have pumped out our precious water to a very large extent. So electricity should not be made free for the farmers. Well, I mean, I should not be taken as I'm anti-farmer. I'm pro-farmer. And most of that water which they pump out is harmful to them. It's harmful for them because it will not be available in the time they need it. So they are to be, say, awareness. That is very important thing. I think our green revolution first, I closely watched it, and farmers were trained, and that brought the green revolution. But we taught them about seeds. We taught them about sowing techniques. We taught them about plowing techniques, harvesting, and then insecticides. But we have not taught about water management. So if we are heralding for a new green revolution, management of water should be taught to our farmer friends.
Definitely, sir. I think it is the need of the hour to actually collectively take people all together and work for this step. It is not one person's responsibility or one person's burden or rather one person's job. It is going to be a collective reform, then only we can bring the change.
Anybody who is little wiser should tell to someone who is less wise on particular subject, you see. Say, we don't need huge setups of teaching centers and all this to the farmers. I'll tell you an example of North America. I was there. Computers, when they started coming, and somebody buys a computer, he goes to somebody who has bought it 2 days earlier and learns from them how to use it. And then a person who has bought today will teach 10 people who have bought 3 days later. And like that, the entire population became computer savvy. They have not gone to universities. They have not. So for these teaching, water management and all this, what we need is from man to man transfer. Wiser people should keep on spreading the word that this is what you should do, not pump out the water if the free electricity is available.
Definitely, sir. That's the need of the hour. Any other questions any of the participants would like to ask?
Yeah, sure. Why not?
I think so more than questions, there have been huge compliments for you. All the participants have thoroughly enjoyed and being enlightened with all your wisdom. And, on behalf of Jharkhand Lake City University and all the organizing team, we thank you so much, sir, for a valuable time and contribution and enlightening us with such a great concept. Sir, before we end the session, I'll request everybody to kindly switch on the camera so that we can have a virtual group photograph. I see so many smiling faces, sir. That is all because of the lecture, I believe.
Great. I'm thankful that you have listened. But as we have discussed, you should keep on providing this information to as many as people you can do it. You teach, make the students aware, let them go and tell their parents, let the message should go through the word of mouth. That will be all right. And you have my, you can get my address and email, and you can contact me. I'm available all the time.
Definitely, sir. We'll share it with the participants.
Yeah.
Thank you so much, sir.
So I'll answer any question in future. If you encounter any problem, I'll be there. All the best.
Thank you so much, sir.